Atomic number, exactly. And what is the atomic number relative to the element? Number of protons, exactly. You got it. So the periodic table, the way it got the word periodic is because it's arranged with periodicity in mind. To me, what screams periodicity is a Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. Okay? So we have days of the week. And I could ask you what Sundays, what do you think of Sundays? And it might be the dread of Mondays. I could ask you, what do you think of Wednesdays? And it might be hump day. I could ask you, what do you think of Fridays? And you're like, yay, today's a Friday. And then we do it all over again. 8, 9, 10, 11, 12, 13, 14, and then we do it yet again. 15, 16, 17, 18, 19, 20, 21. Okay? So again, I could ask you, Sundays have something in common to you? Fridays have something in common to all of us? Wednesdays, hump day. Okay? Our lives are periodic, and so are the elements, and that's the way that's why the periodic table was set up as it is. As it turns out, we could call those 1A groups, lithium, sodium, potassium, rubidium, cesium, francium, we could call them Monday. Okay? They all behave similarly. They have some very similar important characteristics. So that's how that goes. So as it turns out, this that I have circled, we call those groups. So groups would be like the day of the week, and the week themselves are called periods. That's how that works. Not to say there's no relationship between the same days of the same week, but there's less of a relationship like that than there is the up and down in the groups. So periodic table, notice it's missing a few. Okay, so is this one missing a few? But the one that you're going to have Thursday's test actually has it all filled out, if I grab the right copy anyway. Okay. You see the increasing atomic number, like you guys told me, number of protons increasing from left to right. And if you're going to see a periodic table, it'll have the symbol of the element, the atomic number, and then what's that decimal number? Mass, the average atomic group, exactly, mass. By the way, I did look it up and I posted it on Twitter because I think we're, it's not too hard to read on Twitter why this only has 2 decimals. It's like, oh yeah, that makes sense. And again, it has to do with the instability of the different isotopic forms of lead. So they try to chase it down. The most they can chase it down is the nearest tenth of a decimal. So most periodic tables should have this, I call it the JAG. It should have this JAG. Actually, when I started teaching, I was in a room over there and had a humongous periodic table on the board. It's like 1984. It's the same periodic table that's in Chem Lab now because I've got it moved. And that periodic table didn't have this JAG. Like, really? Are you serious? Because there's ways to chunk up the periodic table, and the JAG is an important one. So the way this works is the term metal, these are all metals, and we'll talk more about these guys down here, but they are metals too. And just these little guys are nonmetals. Reminds me of Christmas, got the whole red-green thing going on there. So of these elements, which one has more? Are there more metals or are there more nonmetals? Definitely more metals. Exactly. So when we go to talk about salts, the word salt, think sodium chloride. If I suggest salt, sodium chloride. Well, all salt is it takes a metal and a nonmetal. So sodium chloride is an example of a metal, sodium, and chlorine, a nonmetal. So the term salt is just a generic word for a type of compound. In chemistry, it's not always NaCl. Salt is not always in chemistry's terms something you want to put on your food ingredients. Okay. So anyway, metals and nonmetals. So then we have, and I'll kind of go back and forth. Can you kind of see this periodic table? It's kind of a green looking color there. Silicon, germanium, arsenic, antimony, tellurium, and I think that's astatine. Okay. So those actually lie along the JAG, and they kind of have properties of being metals and nonmetals. They're called metalloids. And I kind of tease, but it's not really teasing, it's actually true, that depending upon which group of chemists you ask and what their mood is, they might kind of look at the JAG and say, well, I think that's a metalloid too, or no, I don't think that's a metalloid. So there's a little bit of a, you know, so these are the metalloids, semi-metals. Okay. So this is going to kind of go across, highlighting the groups. You're going to want to kind of get a handle on groups versus periods. Groups are up and down. Groups are like your Mondays, your Tuesdays, your Wednesdays, your Thursdays. And groups have a designation at the top. Okay. Let's see. This periodic table, and I don't want to mark it up or anything, but notice the 1 through 18 up here, the groups 1 through 18, that's not the designation I usually go with. Instead of that, what you're going to see me go with is, I'll circle them. The group or the column designation are this 1A, 2A, then we skip the B's, and then we go 3A, 4A, 5A, 6A, 7A, and 8A. Okay, that's my designations. And then our B's are right here. Okay, and I'm going to kind of talk about these guys coming up. Okay, so that's the column designation. That's the group designation. And then, okay. So first 2 vertical columns and the last 6 vertical columns. What they have in common is they are all A's. They are all A's. Okay? They are called the main group elements. Now already we're chunking up the periodic table differently, aren't we? Do you see some of the main group elements are metals, some of them are non-metals? Well, all right, welcome to my world. But are all, does this make sense if you find the JAG? All, how to say, non-metals are main group elements, right? So these B guys are called the transition elements. So again, chunking up the periodic table. Main group elements, transition elements. So up and down, or a column is a group. A row is called a period. So these are all the periods. And they also have a designation. And I bet, I'm going to go over the periodic table, and I bet it has the same designation I'm used to. Yep, I can see it from here. See these red numbers? Okay, so this is period 1. This is period 2. This is period 3. Period 4, we pick up the first group B elements. Period 5, etc. Okay. And on your black and white periodic table, you're going to get on Thursday for your test. It's going to have those little numbers over here. Okay. Well, let's take a look at these guys I kind of put in parentheses. Just sit down and like you did, like you weren't late. Let's pretend. So, it kind of makes most sense if you look at their atomic number. So here we have 55. This is what, period 7? We have 55, or is it period 6? Period 6, final answer. This is period 6. We have 55, 56, 57, and then it jumps to 72. Well, 58 through 71 is down here. So you kind of have to think of these guys as kind of lining up in kind of the 3B group. These guys, starting with cerium, the lutetium, I can't remember what the LU, atomic number 71 is, but they kind of come out from the board like 3B. And then it picks up with hafnium, blah, 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 blah. We have the same thing with atomic number 89, because we go 87, 88, 89, 90, okay, to 103, 104, okay, so they kind of pick out like that. So these guys with period 6 down here, these are sometimes called the inner transition elements or inner transition metals, because these inner transition are always going to be metals. They are sometimes called the lanthanide series because they start with lanthanide. Okay? So you probably know what's going to come next. These guys down here are sometimes called the actinide series because they begin with actinium. And some of you guys might remember, and it's going to come up. When is it going to come up? Gosh, I don't know which part of this course. We're going to talk about electrons. There's different types of electrons. There's S-type electrons, P-type, D-type, and F-type. Don't worry if you don't remember it. But anyway, these are actually where we're picking up F-type electrons. That's kind of why that's one way to draw it. Okay. So collectively, the lanthanide series and the actinide series are called the inner transition metals or inner transition elements. Same thing. I kind of use that interchangeably. All right. Well, there are some groups, and this semester I'm adding 2 new groups, so I'm pretty excited. Remember, groups are like the columns. There are some groups that you need to know the fancy name of. And the first one is the alkali metals. So actually, these guys all behave similarly, and they're called alkali metals. And in my way, they're group 1A. The next one you also need to know the name of. They're called the alkaline earth metals. So we have alkali with no N, alkali metals, and then we have alkaline earth metals. And I could sometimes get those mixed up, and I think 2A, which is what these are, the name is longer. So it's the alkaline earth instead of alkali. Now these are new to me. We're going to skip over here to our other group A elements. Don't have to worry about 3A or 4A, but 5A group elements are called the, I'm not sure how you pronounce that, pictogens. But you can kind of see nitrogen in that. And actually, I should have clicked on the button because as I was getting ready for today's lecture, it said, how do you pronounce this word? But I did go ahead and push something out there on Twitter, a little write-up about it. But so 5A would be this group, 6A, which is new for me. 6A would be this group, chalcogens. I forgot that. Okay. That's new for me. The last 2 groups then, kind of finishing up the main group elements, or what we call group P elements, those names are familiar to me. You probably heard of halogens. So 7A are the halogens, collectively the family. And then some of the most awesome elements are those 8A elements. And they actually have 3 names. So as some of you know, with those 8A elements, when we talk about an atom wanting to pick up electrons to become an anion, negatively charged, or kick off electrons to become a cation, positively charged. I don't know if you remember, but they're going to do that to get like these guys over here. Electronically speaking. So they're called noble gases or rare gases or inert gases. Noble and rare because they are not very abundant. And inert because, like an inert ingredient in your medicine, they don't do anything. They don't like to react with other things because they already have a complete octet, or do it in case of healing. So remember that for your Unit 1 exam, actually for the whole course, I'm going to count on you being able to spot or connect up the name with the symbol for these elements. Now, I was talking to my husband about this, and I've seen this especially in my intro to Gen Chem. Sometimes students will only focus on that task. They'll take their periodic table and they'll do some cool highlighting, which I'm not opposed to, and they'll say, I can tell you what the symbol for silver is. I can tell you what it is for gold. I know what it is for lead, for iron, for the hard ones, potassium, K. I got that down. I'm ready for my test. Well, you're ready for that part of the test. Okay, so, and actually, I mentioned throughout the semester, because I'm going to be kind of throwing out terms, throwing out elements, and assuming that you know what the symbol is. So that's here to stay. So we talked about physical properties. These are all kind of a set of physical properties. And remember, the jag separates what the metals from the non-metals. You told me there's a lot fewer non-metals than there are metals. And so we could say with regard to conductivity, the metals tend to conduct heat and electricity. Okay, they're good conductors. Non-metals, not so much. These three kind of go together. If you think of, to me, when I think of a metal, I think of copper or aluminum, and I think it's shiny, that's lustrous. I think it's malleable, which means I can kind of flatten out. Ductile is kind of related to malleability. Can I draw it into a wire? So in those terms, I think metals got it going on and non-metals don't, and you're right. Physical phases, 3 physical phases, gas, liquid, and solid, and by far most of the elements are solids. So remember that, and we'll talk more about this in general chemistry too, but atmospheric pressure, not only temperature, plays a big role in what physical phase something's going to be in. So you put those substances here at normal atmospheric conditions on the Earth, normal temperatures, and we've got these gases here. Can you see our Hofbräunickel there? Nope, bromine is a liquid. So, but anyway, so we have these gases, we only have 2 liquids. Okay, that's bromine and mercury. And then the rest are solids. Here's some pictures. Maybe you've seen them too, and maybe I'll find a link because there's some periodic, periodic tables, but they're like maybe literally a table that you can spread out on, and they have like little cubbies that have the different elements, the little samples in there. So only rich people can have those. So this is due then on the next time we meet, which would be Monday. And we're kicking it with Unit 2. So any questions?
Will it be Unit 2 when we're doing time?
Most likely. She asked, will we finish a part so there will be Unit 2 assignments? Probably, we're just going to kind of keep pumping along in Unit 2, so count on assignments due Monday, or something assigned Monday and something assigned Wednesday. Yep.
Test Thursday, right?
Test Thursday. Okay.
Wow. Work tonight?
Yeah.
You work every night?
Pretty much. He kind of hates me.
Brandon?
Like, you know Tanner, all he does is work. He has 22 hours and he gave me 33 next week.
I'd say the same for Royce, but we just don't have any.
Wait, is Tanner only?
Yeah.